Hi, everyone. I can hear myself. So I'm Louis. I'm the head of product market strategy at Starkware. And today I will be presenting a work in progress we're doing for the last couple of years, which is what would a perfect chain look like? And as the title states, there's a bit of Bitcoin in it. So let me just, disclaimer, this is a work in progress. It's not directly related to Starknet per se. There is some starting part in it, but here it goes. So for those who ask us why do we care so much about blockchain, is because blockchain it's a bit weird. Like it tends to be a lesser technology, a lesser database than any database we have in computer science forever, except in one dimensionality. It's the only database that is trustworthy. And so today, the way the system of traditional computers, like traditional works, is through trust. So you trust a centralized entity, you trust your bank, you trust Google, you trust various providers that will be keeping and running the things for you. And this trust, its integrity is integrity by delegation, it's based on reputation. On the other hand, blockchain came along, Bitcoin, Ethereum, and it based trust on transparency. It's integrity by transparency. The problem is it sacrificed privacy and scalability. So so we have this balance, this challenge between the big computer that work very, very fast, it can do things that we expect the web to do, and the system that tends to work very slowly. So the question we try to optimize when it comes to blockchain is the following ones. We want a system that is inclusive verifiable, meaning how easily I can verify. This is important, I'm going to explain a bit more. Permissionless, how can I always participate in the system? And censorship resistant, meaning can I guarantee that a transaction will always be included? When it comes to decentralization, I want to specify a bit of context here, what it means. Decentralization means the following thing, and we're going to see that in the rest why it matters. Decentralization means it's an objective metric of how easy is it for me to run a node in the system. And so a bit of timeline of blockchain design. So the history of blockchain, blockchain came, the building blocks starting in '91 with things like proof of work. Then we have example with B-money, BitGold, and various systems that try to give the cypherpunk objective of creating independent money on the internet. And then in 2008, the Bitcoin paper came along. And I invite you to read what it does to do. It was try to achieve a peer-to-peer version of electronic cash. So if everyone have read the Bitcoin paper, you have to. It's a must-have. You cannot work in this space if you didn't. And since then, we have seen a tremendous explosion of new technique at the various parts of the tech stack. In the cryptography front, in the consensus front, at the mempool, and at the data structure. And now the question is, what have we learned in 15 years? Actually, this is 15 years. First of all, before, we didn't have ZKP. So we didn't know how to do efficient verification. In the meantime, also, we understood much better how consensus work and what are the properties of consensus that a blockchain should strive to get at. So there is a question of how responsive it should be, how fair it should be, the complexity of communication, and also what it means to be ordered. Additionally, there is a new type of threat that came along, the mempool. So before, we didn't know MEV was a thing. It was written as a research paper by Flash Boys guys in the 2018, but now it's very much a massive industry and massive threat. And finally, we learned that the biggest issue is state and the state growth. So now, can we do better? And what if we were to rebuild a blockchain from scratch? What would it look like? And the point is that it's always been sharding. It's always been. So ideally, what you would like is an L1 that is extremely simple and can do three things. It's very easy to verify, instant, can verify on phone, permissionless, meaning the consensus is accessible forever, and finally, censorship resistant. So let's look at what it would look like. The ideal L1 would look like Mina, meaning a recursively proven chain that can be synced on my phone in less than a second. Except that Mina is missing one massive aspect, which is what we call credible neutrality. Meaning, when this system was created, was it written to privilege a certain type of people? Was it fully open source and very easy to execute? If it's simple, can I understand it? And does it change to often or not? And so, so if I were to create a new L1, ideally, as I said, what you would have is a ZK chain, and I will also want something that is fair. And the reality is that despite everything we say, proof of work versus proof of stake, proof of work remains a very efficient, a very fair way to distribute token. You pay with energy, you get token in return. Additionally, you want something that keeps simple. So you don't want to do much complex stuff at the mempool level. And finally, you want to cap the state, because this allows you to avoid running into infinite problem of state growth. And so the cool thing is, it's kind of feasible. And Bitcoin allows you to do that without having to do much change there. So Starkware and with the ZeroSync Foundation, ZeroSync Foundation built using the Cairo and the StarkNet stack, a proof of Bitcoin. So how does it work? Basically, they implemented a Bitcoin node in Cairo, and I've been running this in mainnet, running in production for the last 6 months. So if you go to their website, zerosync.org, you can actually sync Bitcoin on your phone in 2 seconds. And this is what it looks like. And so this is where Bitcoin has a very interesting opportunity here, because it's very neutrally credible. There is nothing more credible than Bitcoin worldwide. Additionally, on the text front, Bitcoin is extremely simple. The UTX model is perfect for parallelization because it's completely parallelizable at every level. And it's actually extremely compelling for ZK rollup. Why? Because ZK rollup do not need composability between contracts. Ideally, what you would like is also it would allow for so as right now, especially right now, what we're seeing is that a lot of demand for Covenant and a new opcode to allow Bitcoin to do more things. And so if Bitcoin were to adopt this kind of technique, this allowing memory, then on the pure technical aspect, Bitcoin has a very interesting properties. And so to summarize the design, to go back to what an L1 would look like, it would basically be Bitcoin wrapped into a Stark and basically keeps what it is. So what about the L2 now? That's where the L2 becomes a bit more interesting. On the L2 front, what you have is that you want an L2 that is smart contract based, that allows you to do all the advanced things we want to have. You want something that is also very efficient to prove, because you need to prove it to a very simple layer, which is Bitcoin. You want something that is highly parallelizable. You want something that is optimized in a way that allows you for good UX. You want something that sort of learn all the level of optimization that we learned in the last 15 years. So recursively proven, enshrined into the L1, and with also the ability to have arbitrary DA, allowing it to either store on-chain or off-chain, and ideally also would allow for threshold encryption, meaning allowing for the mempool to be hidden to protect against AMV. And this is where this all comes down to this recursivity. What you want is a system that can prove itself to itself up to this tiny, tiny bit of information that can be verified by phone. And when it comes down to defining the L3s, you want also this recursivity, you want the arbitrary DA, but what you want also is to add literally the thing that you can define what you want for every other thing. You want the consensus, you want to be alone on it, fine by it. You don't need fees, first fine. The mempool, you can do FIFO, you can do whatever ruling system that you want because it's a sovereign environment. And so the reason I sort of brought that all together is because I want to give a perspective of like this recursivity and what it means towards scaling. It means that anyone can develop their own application at their own space while having a system that can be run on the phone of a kid in Nigeria. And so the cool thing is it's kind of what StarkNet gives you on top of Bitcoin. This is kind of where I was going at. And the reason is that if you look at all the optimization, all the learnings, because StarkNet was built from the bottom up and from the ground up, we were able to take all the advantage, all those learnings into the consideration when making the VM. And what makes me very excited is that we are already starting to see people using the StarkNet stack, the Cairo, and improving the state of Bitcoin as we speak today. Zero Sync as one of them. Starkware just launched a new restaking solution using the StarkNet stack, and I expect to see a lot more of the Stark-based solution reaching to Bitcoin. So there is a bunch of also open questions going on, such as that still needs to be resolved. State growth. No one has truly solved the problem of state growth because the old idea that state rent and all of that tends to be, which are ideas about allowing people paying in advance for how long I'm going to keep this thing in memory, are not very practical in terms of UX. There is a bunch of questions. What does it mean to be what does the governance of an L2 looks like? Because governance of an L1 is easy, in some sense, because it's rough consensus. I don't have to have a ruling system. I don't need to vote. I'm going to say, we all agree. Let's agree on that. That's fine. And makes a very slow system and a very robust system. On L2, the biggest issue that you have is you have this question of upgrade. How do I upgrade? How do I activate this upgrade and change the OS, change the mechanism, change the consensus? And those makes you vulnerable to all sort of governance problems that you see in crypto today, in all the DAO systems, such as the lethargy of the voters, people not having the interest to actually vote, the bribing, in all sort of the oligarchy where people try to attract to themselves a significant chunk of resources and dictate a dictature of the majority. Another one that is barely talked about, which interests me very much, is called historic growth. Because where ZK comes along and solves things when it comes to scaling is that it allows you to forget a lot of the computation and forget the transaction data. Except that the transaction data has value. And right now in any blockchain, the way we're thinking about it is storing into the full node. And the full nodes keep growing forever without expectation of, there is no way to basically solve that. So no one really cares about this, but when you think about blockchain not only as like an ongoing system, but also an auditing system, an accountability system, you also want to look at the path. And there's kind of a story that has been solved yet. Additionally, you have another problem with POS, that is true for any POS system, which is the oligarchy problem. Meaning, in POS as of today, the rich get richer. You cannot kick out someone from the staking system because unless if they participate, which means that if I keep going and tomorrow this token, this value become like one of the biggest value in the world, you have people who just remain rich forever. And finally, there are even more questions about how do I get the data of this chain to even harder devices than just more smartphone, smaller devices, like embedded devices. So I will just finish on this note and open question for people to think about. But just want to say that we are getting closer to that word. Ethereum is simplifying or trying to prove itself. Bitcoin is changing too. And I do see a world where StarkNet and all the ZK stack gets deployed to those infrastructures, especially Bitcoin, and gets us to the next level of what the blockchain will be and look like. Any question? Yes, go ahead. Wait.
Thank you. Would you say that this is competitive with StarkNet on Ethereum, or is it, friendly?
No. So that's the thing. It's not. It doesn't have to be. And there are some research has been doing within the Starkware and the ecosystem about showing what does it mean to have L2 that we mean. This is hypothetical, right? It's not happening yet. But what an L2 would look like if it was to settle on multiple chains at the same time. And so to give you a brief idea of what it looks like, basically it would be so what would look like would basically each environment, each L1 would be a volition of the other. Meaning, for those who are not familiar with volition means that some data is on-chain, some data is off-chain. And if I want to be aware of what's the off-chain data, I need to be syncing with the L2 itself. I need to trust the L2. So if I were to settle on a two L1 at the same time, what it would mean is they actually don't have to necessarily need to synchronize, but it means they are volition of each other. And so what my risk as a user is if I'm only doing Bitcoin stuff on the Bitcoin part of the DA, then I'm actually protecting against any misbehavior on what's going on the Ethereum side. On the other hand, if I'm doing things on the Ethereum side and something happened on the Bitcoin side, I don't care. Where I do care is I care for the duration. If I do a swap, let's say ETH to Bitcoin on this L2, then what kind of problem you have here is I need to trust that the L2 will not commit two different proofs. It would sync itself through the different chains. So that's one design space. There is also the other design space where we actually prove the inclusion of the data itself to unlock things. But I think this is like a very ongoing research. But I find that very exciting in terms of what it means and what we allow. And once again, it's very theoretical at this stage in terms of like research and what are the implications for one layer to settle across multiple ones.
Thank you. Yeah. I have a follow-up question if no one else.
Go ahead. You're one of many.
Yeah. So I mean, knowing the blockchain space and the community of Ethereum versus Bitcoin, Bitcoin can be very skeptical of anything that adds functionality past what Bitcoin was built for.
Yes.
Do you find that maybe the most challenging part of having something like this succeed because the community itself would be pushing back, similar to what we see with ordinals? So
I mean, so this is more like a meta question. It's not really starting per se. Like it's like there is two parts of the question. Like, let's say tomorrow Starknet were to settle on two chain. It's hypothetical, right? Who would be most upset? That's basically the starting point. Would it be Ethereum or would it be Bitcoin? Probably both, and different people. No, if the reality is the Bitcoiners. I mean, as you said, like there is a huge tension in Bitcoin right now to add basically covenant. And on the other hand, Ethereum a lot of Ethereum core would feel like betrayal if someone were to go that path. Now, is it a risk that Starknet should take? I don't know. But if it's something that is interesting and intellectually challenging and interesting to think about, that's something I'm very much in favor of. So this is where this presentation comes from, more about what happens if we go that path rather than what, like technically speaking, what does it look like? What does it provide? What's the use case? Versus, on the other hand, trying to go the politics of what the practical implementation in the end.
That's all right.
Any more questions? Think we're good? Oh, yes.
I'm not sure how to phrase this, but do you think there will be a single source of truth for?
So this is.
Yeah, is there going to be a momentum towards like a single source of truth?
So in the design I just described about assuming two settlements on two different chains, right? The same settlement on two different chains. No, but actually it goes even deeper than this. It reminds me of like so in 2019, I attended a course from Hebrew University, which was distributed computing and blockchain. And it's very interesting because you can theorize the knowledge of common knowledge as to be something that is person-specific. So your ground truth is what you look at and what you believe in. So if there are ground truth of things, their answer is like even in blockchain itself, there is no such a thing as ground truth. There is a probabilistic behavior of so on the synchronous consensus, there is an assumption that within 10 minutes, you're going to know, on Bitcoin, within 10 minutes, you will know that this happened. Or in the asynchronous proof of stake, 66% assumption, I will know even if I connect down the line. Like this is, so there is a very big difference in like the biggest difference between synchronous is, do I assume that I'm connected and I will get the message, or do I assume that I will not be connected and I can get any time in the future? So to answer your question about, is there going to be a single source of truth? The answer is, I don't think so. Because even truth is something that you self-define as what is true. Some people would take Bitcoin Cash as a truth of the source of truth for Bitcoin, when some other would just take the Rigor chain as a source of truth. So to summarize your answer, I don't think there is such a thing as a single truth when it comes to blockchain, because it's agreed upon and it's a local based on what you receive and what you know. Any more questions? I think we're good. Perfect. Thank you so much.